Patients on benefits and risks of ionizing radiation. First, let me introduce you to radiation. What is radiation? Radiation is energy traveling as waves or particles. There are two forms of radiation, which are electromagnetic radiation and particulate radiation. Electromagnetic radiation is pure energy with no mass and is like vibrating or pulsating waves of electrical and magnetic energy. It also acts like a stream of small packets of energy called photons. Examples of this kind of radiation are X-rays and radio waves. Another kind of radiation is particulate radiation. It is primarily produced by disintegration of an unstable atom to achieve stability. Examples of this kind of radiations are alpha and beta particles. Okay, I want to ask you, do you know that we are exposed to radiation in our daily life? Yes? No?
Yes.
Yes.
Of course, yes.
Yes, it's good. Okay, now let's see. In our daily life, we might get exposed to radiation that come from the building that made up of radioactive materials, radiation from the X-ray, radiation from the TV and computer, radiation from the food such as the banana that contains naturally high level of potassium, and a small portion of this potassium is radioactive. And we also have radiation that come from tobacco that is made up of radioactive element, and radiation that come from radon that usually found in soils and rocks under the ground, and radiation during flight, in which at higher altitude we get to exposed to cosmic radiation. Okay, radiation can be classified into non-ionizing and ionizing radiation. Non-ionizing radiation deposits energy in the materials, but it does not have sufficient energy to break molecular bonds or remove electrons from atoms. Examples of non-ionizing radiation are radio wave, microwave, infrared, and more. Ionizing radiation, on the other hand, has sufficient energy to ionize atoms, which means it can remove electrons from atoms, which can change the chemical composition of the material, which can damage the DNA. So, tonight, my group will focus on this ionizing radiation.
So, how radiation interacts with human body? What actually happens when radiation interacts with human body? Our body is composed of trillions number of cells. They provide structure for the body and carry out specialized functions. Cells also contain the body's hereditary material and can make copies of themselves, and we call this as DNA. DNA is the hereditary material in humans and almost all other organisms. Most DNA is located in the cell nucleus. Next slide. There are two ways the radiation can interact with our cell, which is direct action and by indirect action. For direct action, it involves charged particles such as electron, proton, heavy ion, alpha and beta particles. These particles will interact directly by striking the critical targets in the cell. The atoms of the target itself may be ionized or excited and initiate the chain of events that lead to biological change. While for indirect action, it involves X-ray, gamma ray, and neutron. They have sufficient kinetic energy to free an orbital electron, producing a fast recoil or compton electron. According to International Atomic Energy Agency, about 2/3 of the damage caused by X-ray is due to indirect action. This indirect radiation occurs when the radiation does not strictly strike the DNA, but instead it interacts and strikes other atoms or molecule, which is commonly water molecule. This will ionize the water molecule and eventually producing what is known as a free radical. Free radicals are highly reactive molecules that are able to diffuse far enough to reach and damage the critical target. Next slide. Radiation and electron bombarded by radiation move haphazardly inside the cell, resulting in damage to the various molecules forming the cell, which also bring damage to the DNA as the DNA is inside the cell. The damage will occur either at the base of the DNA or at the strand of the DNA. Next slide. There are three types of damage that can occur at the base of DNA. First, let's take a look at the normal DNA structure. This is the normal pairing of DNA bases. Adenine is paired with cytosine is paired with guanine. So what happened in the first type of DNA base damage is missing base, or we also call as a basic site. As you can see in the example here, one of the base is missing. The thymine base here should be paired with adenine, but the adenine is missing. Basic site are one of the most frequent spontaneous lesions in DNA. They are potentially mutagenic and lethal lesions that can block DNA replication and transcription. Second is base modification. It is caused by changes to the DNA bases themselves. It occurred when adjacent base is covalently linked to each other and resulted in replication as a single base, which result in frame shift mutation. And the third one is base mismatch. These are caused by replication error, which lead to mismatch of bases. In this example here, the guanine is wrongly paired with thymine, when the correct pair should be the cytosine. Next slide. And next is damage to the strand of DNA. First is double strand break. This is where both strand backbones of DNA are broken. This type of break is most lethal sort of lesion. Second is single strand break. It's break of only at one side of the DNA strand, and this will result in a partial separation of the affected strand over several nucleotides. And last is inter and intra-strand crosslink. For intra-strand crosslink, it occurs when cross-linking agent covalently connect two nucleotide bases from the same DNA strand, while for inter-strand crosslink, the cross-linking agent covalently connect two nucleotide bases from the opposite strand DNA strand. And all these DNA damage from radiation exposure can cause various kinds of disease.
Today, to benefit humankind, radiation is used in medicine, industry, as well as for scientific research. In addition, radiation has useful application in such areas as agriculture for food irradiation, eradication of insects, and many others. Next slide. The first application is in medicine for diagnostic and therapeutic purposes. Today, the use of ionizing radiation is divided into three medical specialties: radiology, radiotherapy, and nuclear medicine. Radiology uses X-ray to produce diagnostic image. In radiotherapy, various radiation generated outside the human body being used in order to obtain therapeutic action. Meanwhile, in nuclear medicine, radiopharmaceutical will be introduced into human body to obtain diagnostic image or therapeutic action. Next. The next benefit of ionizing radiation is for food irradiation. Why is food being irradiated? So anyone want to answer?
To prolong the ketahanan dia, preserve the food.
Yes, true, Husna. And someone answered in the chat box, there is to kill bacteria that can cause food poisoning. Also correct. So food irradiation using gamma source can serve many purposes. The first one is to kill bacteria that can cause food poisoning. That's mentioned by Miss Afika, such as Salmonella bacteria that can cause diarrhea, fever, and also abdominal cramp. Also, food irradiation can serve to destroy organisms that can cause spoilage and extend the shelf life of food, as mentioned by Husna. Besides, this process can destroy insects on imported fruit and inhibit sprouting and delay ripening of fruit to increase the longevity. But it must be noted that food irradiation does not make the food radioactive. The food itself never physically in contact with the radiation sources, and the nutrient loss caused by irradiation are less than or about the same as nutrient losses caused by cooking or freezing. Next. The ionizing radiation is being utilized in various sectors. For example, in automobile industry, the radiation is used to test quality of steel in car. Pipeline companies make use of radioactive isotope to validate the integrity of the pipeline. Aircraft manufacturers also use radiation to check for flaws in the jet engines. Radioactive material also being used to gauge soil moisture content and also asphalt density in the construction industry. So this gauge will ensure that safe building and roads are being built. And lastly, mining and petroleum companies use isotope to locate and quantify geological mineral deposit. Next. The use of ionizing radiation also include eradication of insects. So why we need to eliminate this insect? While some insects are important for maintaining the natural ecological balance, others can destroy valuable food crop. Some insects such as mosquito and fly are vectors of infectious disease. So to eradicate the insect, we will use a technique that is called as sterile insect technique. So in this technique, the laboratory red male insect is being sterilized before they hatch. So after they hatch, they will be released in a large number in the infested area. And when they mate with the female, there is no offspring produced. Next. So the last one is in scientific research. So archaeologists will use carbon-14 to date the artifact that contain plant or animal material. And also criminal investigators use radiation to examine evidence in criminal investigation. For example, forensic will use X-ray to examine the sample found, for example, in car tires, footprint that may provide the link between a criminal and also a crime. Next.
Okay, so what is the risk of radiation to human body? Typically, when we talk about radiation, we always relate to the cancer. So I would like to ask you guys that the one chest X-ray or one of CT scan increase our risk of cancer? What you guys think? No? Okay. So let me explain about the radiation hazard scale and effect of radiation first. Next slide. Okay. Radiation hazard scale have 5 categories, which is category 1 means that the radiation level in the environment are within the range of the natural background radiation for the geography area, which is as low amount the radioactive material exists naturally in our environment, or food, air, water, and constantly to our body. Which is for the second categories means that the radiation level in the environment are higher than the natural background radiation. However, this radiation level is still considered as too low to observe any health effect. For the third category means that the radiation dose are becoming high enough which the aspect increase the risk of cancer in a years ahead for the people who are exposed. So for example, leukemia and the thyroid cancer can appear in as a few 5 years after the exposure, or other types of cancer can take decades to develop. And then for the fourth category means that the radiation dose are dangerously high and can make people seriously ill. Radiation dose are not higher enough to cause death, but one or more symptom of radiation sickness may appear. And then the early symptom may include like nausea, fatigue, vomiting, and diarrhea symptoms, such as hair loss or skin burn may appear in a week. And then the last category, which is fifth category, means that the radiation dose are dangerously high and potentially to the lethal, which is a high dose of radiation can cause massive dangerous to the organ of body and kill the person. Next slide. Okay, this is a chart of the radiation dose in our daily life. As we can see, it's only 0.05 millisievert, which is the average effective dose from the single chest X-ray. And the International Atomic Agency, which is IAEA, limit for the public exposure for ionizing radiation is 1 millisievert per year, excluding what the person normally receive for the normal background radiation. When a human body receives a high radiation dose of the normal of more than 1 sievert, not 1 millisievert, is in a short duration, can cause a radiation sickness, which is when they exposed to the whole body radiation dose above 10 sievert, it lead to death. It takes a very high radiation exposure to cause the radiation sickness. It is equivalent to getting 18,000 chest X-ray distributed over your entire body in a short period. For the scientific study shows that the damaging effect of ionizing radiation are greatly reduced when the radiation dose is delivered in a small amount and spread over a long time period due to the greater body repairing of damage. And then, however, when exposure to the low level of radiation, it also can increase the risk of developing long-term effects such as a cancer over a lifetime. This is known as a stochastic effect. So my answer for the question earlier, that is true. One chest X-ray can increase the risk of cancer. However, it should be noted that having risk is not equal to you surely being subject of cancer. Next slide. Okay. There has two types of radiation, two type of effect radiation to the human body, which is a radiation effect may also be classified depending on the length of time until any symptom appear after the exposure. The early effect appear relatively early after the exposure, which is the most common early side effect of vomiting within the several hours after exposure, hair loss, diarrhea, continuing for several days of several weeks, decrease of the number of blood cells, bleeding, and so on. And the early side effect also usually are related to the area being treated, such as a mouth problem when the radiation treatment is given to this area, and then the lag effect of the late effect that appear after lapse of several months or years. So deterministic effect are a symptom caused by death or degeneration of number of cells constituting organ of tissue and tissue. And for example, after exposure to the large amount of radiation, a skin injury may occur, or we can call it as acute radiation syndrome. Exposure to a large amount of radiation during pregnancy may cause some effect on the fetus, and the radiation exposure to the eyes may include the cataract after a while. We can see that this is a picture of the normal eyes and eyes with the cataracts. However, deterministic effects do not appear unless having been exposed to the radiation exceeding a certain loss level. Besides, stochastic effects are caused by mutation of cell genes such as cancer and hereditary disorder. Radiation may damage the DNA, which may result in genetic mutation. Each mutation is unlikely to lead to disease independently, but theoretically, we cannot be completely denied of a possibility that causing cancer or a hereditary disorder. Therefore, cancer or hereditary disorder are managed on the safe side under the assumption that there is a no certain dose level. Okay. Next slide.
Okay, in conclusion, in general, in the real world, there is no such thing as zero risk. Therefore, justification must be made whether the benefits of use of radiation outweigh the risk. Optimization must be made. If exposure is justified, then keep it low as reasonably achievable. So before we end our presentation, we would like to share a quote from Marie Curie. It says that nothing in life is to be feared. It is only to be understood. Now, it is the time to understand more so that we may fear less. That's all from us. Thank you everyone for listening.
Thank you for your attention.
Thank you so much, everyone. Good presentation for the first topic. If you have any question for them, so please keep your question or you can type in the chat box. We will answer your question after all the presenters have presented their topic. Now we are going to move on the second topic about the non-ionizing radiation. So just now you have at least like learn about what is a ionizing radiation. So now we are going to move on to what is a non-ionizing radiation. Are you ready, Husna?
Yes, Doctor, sorry.
Okay, you can start sharing your slides.
Okay. Sorry, loading. Okay, now. Okay, Assalamualaikum and hi everyone. We will now moving on to the non-ionizing radiation because just now we have learned about ionizing radiation. So the main topic about non-ionizing radiation that we will discuss today is mostly about its effect. So my name is Husna and here I with my friend Sophia. We will today explore more about non-ionizing radiation. Okay, opposite to ionizing radiation, non-ionizing radiation is the type of radiation that does not have enough energy to energize to ionize the atom or molecules. This radiation includes radio waves, microwaves, infrared, visible lights, and UV lights. These type of non-ionizing radiation are being widely used and applied in our daily life. Yeah, you can see this diagram. This is a electromagnetic spectrum. From this spectrum diagram, we can see that the non-ionizing radiation here are those who have low frequency and has and hence they have low energy. Since the energy of particles of the non-ionizing radiation is low, they can only disturb the electron in the atom without being able to kick them out of the atom. So that's the difference between non-ionizing and ionizing. So let's take a closer look at how non-ionizing particle disturbs the electron in an atom. Okay, so as we said before, it disturbs the electron. So this disturbance from the radiation will cause the electron to move to a higher energy levels, like we can see in this diagram, when it absorbs the energy from the heating radiation. So this process is called excitation. So for ionizing radiation, we call that ionization. Instead of producing ions like the ionization, the excitation process will only change the rotational, vibration, and electronic valence configuration of molecules and atoms. This will produce thermal effects. So like from this diagram, we know that the possible non-thermal effect of non-ionizing form of radiation on living tissue only have only recently been studied. Much of the current debate is about relatively low levels of exposure to RF radiation, radio frequency radiation, from mobile phones and base stations producing non-thermal effects. Some experiments have suggested that there may be biological effects at non-thermal exposure levels, but the evidence for the production of health hazard is contradictory and unproven. So, let's explore more about these types of radiation and how they affect our life. Okay, so the first type of non-ionizing radiation that we will learn is commonly used in communication devices such as mobile and laptops that you are using right now, radios and Wi-Fi. So let's hear more about radio waves from Sophia.
Okay, radio wave is the type of electromagnetic wave that has the longest wavelength. The wavelength of radio wave is about 3 cm to 3 km, which longer than microwave and visible light, with the lowest frequency of 3 kHz to 300 GHz. And radio waves do not only provide radio signals, but also carry signals that radio, television, and mobile phones can be used. They are generated by an electrical device known as transmitter, connected to the antenna that radiates the wave.
The next non-ionizing radiation that we will discuss is often known to be in our kitchen, microwave oven. So it is commonly used for cooking purposes without using water. The high energy of the microwave rotates the polar molecules of water, fat, and sugar of foodstuff. This rotation will cause friction that generate heat. Okay, so the excitation by the microwave is almost uniform so that the food will heat up uniformly. The cooking in the microwave oven is fast, efficient, and safe. Besides microwave oven, microwaves also comes from natural sources, such as the sun and cosmic background. For cosmic background radiation, it is thought that it is the leftover radiation from the Big Bang Theory. So, anyone know about Big Bang Theory? But I think most of us have heard about the Big Bang Theory, right?
Yes.
It is
No.
It is the theory that when the first time that the universe began. Okay, the theory goes like this. When the universe is born, it underwent a rapid inflation and expansion. Okay, so that's the Big Bang Theory generally in short said. So in radar devices, point-to-point microwave antennas use these microwaves to transmit use these microwave signals across relatively short distances. These antennas are usually circular dish and rectangular in shape and are normally mounted on a supporting tower, rooftop, size of building, and on similar structures that provide clear and unobstructed line of signal sight path between both ends of a transmission path. These antennas relay long-distance telephone calls and serving as links between broadcast studio and transmitting sites. Let's hear more about the details of microwave radiation from Sophia.
Okay,
Sophia? Sorry.
Okay, microwave in a wavelength range between about 1 millimeter to 33 centimeters and with frequencies ranging from 300 megahertz to 300 gigahertz. Microwave are suitable for wireless transmission signals having higher bandwidth. There are three subcategories of microwave radiation, which are extremely high frequency that used in remote sensors. And then we have super high frequency wave that commonly used in radar transmitter and microwave oven and also cell phone. And finally, we have ultra high frequency that is used in television broadcast, walkie-talkies, and also cordless phone.
Okay, so after we have known about the radio waves and microwaves, I think most of us are thinking that is radio wave and microwaves danger to us? Right. So actually, there are two effects of this radiation, these two radiation, which is the thermal effect and non-thermal effects. In terms of thermal effects, both radio wave and microwaves are giving effect on increasing body temperature and can lead to body tissue damage. Longer directly exposure to radio wave and microwaves could also cause skin burning and cataracts. There is a higher risk of heat damage with organs which are having poor temperature control, such as lens of the eyes and testes. Okay. So as we can see in the diagram, the lower left diagram, you can see that in the left diagram, it is before this man used cell phones. But on the right diagram, this man have been used cell phone for a long time. We can see that the thermal effect has affected its nearly the eyes. Okay, so eyes is a sensitive organ, so it's dangerous to our eyes and can cause cataracts. And also beside other organs that is sensitive is testes. So the testicles are extremely sensitive to elevation in temperature, which can reduce sperm motility. Okay, actually, some experiment has suggested that there may be biological effects of non-thermal exposure levels of microwaves and radio waves, but the evidence of production of health hazard is contradictory and unproven. For example, intensive international research has found no conclusive and convincing evidence that mobile phones are damaging to health in short or long term. However, in May 2011, the WHO, you know WHO? Anyone doesn't know WHO? I think everyone knows WHO. Classified RF radiation as possibly carcinogenic for humans based on an increased risk for glioma, a type of brain cancer. This means that there might be possibility that mobile cell phones can cause brain cancer, but this research is still ongoing. So precautionary approach to mobile phones should be applied in our daily life, okay? So now we have known that our mobile phones do have radiation, but it's not harmful. Let's take precaution steps and limit our mobile phone usage from today onwards, because they could cause brain damage, like what WHO has said. Moving on to infrared radiation. Infrared is rarely heard if you are not moms who love health devices. Okay. Recent developed infrared device in medical is the infrared sauna. This is just being developed. It is based on deep skin penetration of radiation to restore homeostasis of thermoregulation. In patients who spend most of their time seated, for infrared sauna, the sauna could be applied as an alternative to their moderate exercise. They produces therapeutic effect without any adverse effects. Besides health, Infrared is also applied in communication device. Very simple example you can find is in our TV remote control, but mostly us nowadays not watching TV, using iPad and laptop only. So have you noticed that when you hit a key on your remote, the transmitting IR LED will blink very quickly for a fraction of a second. It is the it is the infrared transmitter actually sending encoded data to your appliance. Where did the infrared comes from? So let's hear it from Sophia.
Okay. Basically, infrared radiation or infrared light, it is a type of radiant energy that's invisible to human eye, but we can still feel it as a heat. All objects in this universe emit some level of infrared radiation, but two of the most obvious sources are the sun and fire. The infrared portion of the electromagnetic spectrum can be divided into three categories in wavelength, which are far, mid, and near infrared. Okay, far infrared from 300 gigahertz to 30 terahertz that can be used for astronomy, and then mid-infrared from 30 to 120 terahertz, which hot objects or black body radiators can radiate strongly in this range. And lastly, near-infrared from 120 to 400 terahertz that is usually used for infrared photography and videography. Do you guys know that infrared is used in the thermal cameras and hunt for ghosts? Anyone know?
Never heard of.
Okay, basically it is widely believed by many paranormal activity hunters that thermal camera, it is known for their high temperature sensing capabilities and can be used to detect the presence of those from the afterlife. But how does it work? Okay, this device uses a combination of a complex algorithm, a specially constructed thermal lens, and highly sensitive equipment to detect changes in infrared light around us. And these changes are represented as a thermal image on the camera itself. Overexposed to infrared radiation can cause damage to retina and cornea that leads to cataract. Okay, for biological effect, the cornea, iris, lens, and retina are all highly sensitive to varying degrees of thermal damage. When the cornea absorbs infrared radiation with conversion into heat, this is conducted to the lens. Aggregation of lens proteins after repeated exposure to extreme heat can cause lens opacities or cataracts, as are often seen in glass workers and iron and steel workers. Skin damage due to hyperthermia can also occur, but it depends on the intensity and the duration of infrared exposure. Long-term infrared exposure of the skin without burning, such as after years of skin exposure to open fires, can cause a red-brown mottling of the skin. However, infrared is not thought to play a role in initiating skin cancer. Unmute.
Okay, I'm sorry. Okay, you see the rainbow in the diagram? Actually, for colors of rainbow that we see is commonly cited sequence by Isaac Newton's sevenfold, which is red, orange, yellow, green, blue, indigo, and violet. These colors are actually the different spectrum of visible light that can be viewed by human eyes. Main important of visible light is for human to see actually. So all of us know that visible light is also important for photosynthesis in plants. We will die of hunger without visible light because we won't have food. Application of visible lights also applied in technologies which are lasers, CD players, and laser pointers. Did you know that many objects are actually just reflected from another source? Okay, so let's hear about this more from Sophia.
Okay, the visible light portion of the electromagnetic spectrum can be seen by humans, animals, and other organisms. Visible light in a wavelength range between about 400 to 700 nanometers. This type of light consists of 7 colors as mentioned earlier. And the reason that the leaves of plant appear green in sunlight is that the substances contained in the leaves soak up the blue and red light and reflect back only the green light that reach our eyes. The sun and other stars produce light because they are so hot. They glow with light due to their extremely high temperatures, and this way of producing light is called incandescent. Incandescent light bulbs also produce light in this way. When electric current passes through the wire filament inside an incandescent bulb, the wire gets so hot that it glows. The colors are present at one time and the light is white. So some objects produce light without becoming very hot, and they generate light through chemical reactions or other processes. Producing light without heat is called luminescence. Many other objects appear to produce their own light, but they actually just reflect light from another source. Being lit by another source is called illumination. Everything you can see that doesn't produce its own light is illuminated by light from some other source. The moon is glowing so brightly that you can see shadows under the tree, and it appears to glow from its own light, but it's really just illuminated by light from the sun. Visible light is extremely important to humans as we use it to see. Without light, our eyes would not be able to see images of anything. The visible light radiation can exert various biological effects such as erythema, pigmentation, thermal damage, and free radical production. Visible light is typically pretty harmless. However, some light can be so intense that it can damage the receptor cells in our eye, causing temporary or permanent blindness. High-powered laser can also be damaging and will cause burns.
Okay, so for UV radiation, actually natural source of UV radiations is the sun. It comes mainly from sun, while there are also artificial sources, which includes lasers, halogen, fluorescent, and incandescent lights. I remembered using UV light to cure resin glue in my project. The UV radiation is widely used in industrial processes and in medical and dental practices for a variety of purposes, such as killing bacteria, creating fluorescent effects, curing inks and resins, phototherapy, and sun staining. Different UV wavelengths and intensities are used for different purposes. However, there are reasons why we should avoid UV light exposure to our skin by using sunscreen with certain SPF range that's suitable for us. So let's hear why from Sophia.
UV radiation isn't always bad. In small doses, it actually helps us to produce vitamin D that our bodies need. The problem occurs when UV rays frequently come in contact with our skin. Its effect can be long-term and detrimental. These effects show up over time when our skin is not protected. So this is why we need to apply sunscreen. Sunscreen will protect our skin from UV rays as it blocks the rays, greatly reducing the likelihood of sunburn. Also, by applying sunscreen, we can cut the risk of contracting skin cancer into half. Okay, UV rays are broken down into 3 different bands, which are UVA, UVB, and UVC. UV wavelength vary in size and different in how they affect our skin. UVA radiation penetrates deeper into the skin all the way into the inner layers. They reach deep into the skin and are predominant cause of aging, wrinkling, loose skin, and sunspots. They are not the #1 culprit, but still, they can cause changes in DNA, which eventually can lead to skin cancer. UVB rays come in contact with the outer layer of the skin. It is the most prevalent cause of the redness, sunburning, and skin cancer. These rays can cause changes in DNA in cells directly and be one of the top culprits to the skin cancer. And lastly is UVC. It is the shortest and not long enough to reach our skin. UVC rays are actually the strongest but are mostly absorbed by the atmospheric ozone. They usually aren't destructive to our skin. Okay, there is a rare genetic condition called xeroderma pigmentosum or XP, which basically means a severe sensitivity to sunlight. If sun hits the skin, the person will get skin cancer. The brain starts to fail and could be fatal. So there is a movie related to this disease entitled Midnight Sun. You can watch this movie on Netflix. Okay, last but not least, always remember, block out the sun, not the fun. Let's end our discussion with a quote from Marie Curie. Unfortunately, it is the same as previous group, but that's okay. The quote sounds, "Nothing in life to be feared, it is only to be understood. Now it is time to understand more so that we may fear less." This non-ionizing radiation can benefit and harm us in many ways. All we need to do is to understand how this radiation works so that we can benefit from them without exposing ourselves from their harm. So that's all from us.
Okay, actually, from our long presentation, what I want to conclude is the effect of non-ionization is thermal effect and non-thermal effect. So we have known that there are many thermal effects that can cause health hazard. But for non-thermal effects, such as the radiation itself, there are no proven studies that says non-ionizing radiation can cause like cancer or anything that caused by non-thermal effect. So that's all from us. I'm not sure whether the Q&A session will be after each presentation or in
Husna, we will have
separate slots.
we will have a question after all the presenters have presented.
Okay. All right. Thank you, Doctor.
All right. Thank you, Husna and
Thank
Sophia,
you.
for your presentation. Okay, you can unshare your slides. Group 4, are you ready? Lukman, is it? So hopefully now you have a clear distinction what is an ionizing radiation, what is a non-ionizing radiation, and what are the effects that coming from both types of radiation. Now we are going to move on to the last topic by group 4, and presenters is Lukman. You can start when you're ready, Lukman.
Can you hear me?
Yes, I can hear you.
Okay. All right. Okay, Assalamualaikum and good evening, everyone. I hope you're still in the mood for hearing another, the last topic for today's session. My name is Ahmad Lukman, and along with my teammates Ji Xiaomin, Emily Huang, and Ahmad Faiz. So I'll be the representative for my group for today's presentation on the lethality of radiation towards human body. So there will be 4 subtopics that I will be presenting on, which are the mechanism of killing, what are the effects caused by radiation, the Tokaimura radiation incident, and finally the radiation protection. Without further ado, let's begin. So, mechanism of killing. When we talk about mechanism in this context, we are referring on the process or method for how the radiation killing the cell. So there are 2 distinct mechanisms, which you can see on the screen. The loss of specific function for differentiated cells that do not proliferate, such like nerve, muscle, secretory cell, and or loss of reproductive integrity for proliferating cells, such like stem cells in hematopoietic system or intestinal epithelium. So for those who are familiar with the jargons like proliferate means like multiply, the cells multiply. And like the hematopoietic system is the system where the production of red blood cells. And the intestinal epithelium is a single cell layer around the large intestine and small and large intestine. So DNA is the target. The principal sensitive sites for radiation-induced cell lethality are located in the nucleus, where our DNA is opposed to the cytoplasm. Okay, so when radiation is being exposed to, is being absorbed by biological cells, it targets the DNA, the DNA within the cell. So one would ask, why, of all kind of cells, why is it the DNA? Why? If you're thinking, let's take a moment, think about why. Okay, it can first, the answer is clearly on the screen. It is radiosensitive. Okay, now that we know that DNA is radiosensitive, why is it radiosensitive? Why? Why indeed? Does anyone have their answers or would like to share? Yes? No? Okay.
I'm
You
not
have a,
sure.
I'm not sure. All right, I enlighten you. Okay. So because the inside our cells, the DNA has only 2 copies of itself, while there are thousands of other organelles compared to DNA. So they are so small, which they are so sensitive. Like, yeah, compared to others, there are so many, while they are the small minority. Okay. All right. So moving on, now that we are going through a list of the mechanism of cell killing by radiation. First, we have the bystander effect. Okay, in social, in the social aspect, bystander effect is like where someone in need or need help, but others won't help. Okay, so something like that. So in radiobiological aspect, the bystander effect is where is the ability of cells affected by radiation to convey manifestation of damage to other cells, okay, to other cells, which are not directly targeted for irradiation. So as you can see from on the slide, the radiation is being exposed to these cells, okay, these 2 cells. And then, suddenly because of the bystander effect, the other surrounding or neighboring cells is also affected. So it's more like if I would like to give an for instance, like this says like if I'm gonna die, you're gonna die as well, something like that. Okay. All right. So the most pronounced when when the cell in the process of bystander effect, it's in a simple process that I can conclude. Itself, the irradiated cells sends a signal to the other normal cells, which induce a response through a gap junction communication. So as you can see, this there. So what do the bystander effect does? It causes what? Larger damage area, which is also important for low doses and implication in risk estimation. Okay, moving on. Okay, this is for example the social aspect. Someone really appreciates you. Okay, the person in the middle is dizzy, and then more will fade together. Yeah, like, oh no, I'm dizzy, but then everybody around here, oh, I'm dizzy as well. Okay, so something like that. Okay. So moving on is the next mechanism is apoptosis. Apoptosis. So apoptosis is a programmed cell death where a coordinate sequence of events occurs to dismantle a cell. So the function of apoptosis is to eliminate excess cells, carving out structure and seed, and weeds out aging and defective cells. So it's like a normal cell death. So for instance, let's take this the tadpole and the frog. Okay. So the tadpole has a tail. So in order for it to evolve into a frog, as we know that it doesn't have a tail. Okay. So by apoptosis, the tadpole eliminates the cells, the tail through apoptosis, which to be a frog. So common in embryonic development for obsolete species. So obsolete. This is the term that we're going to we should highlight. Okay. So, and also in hematopoietic and lymphoid cells, highly cell dependent. So, defects in apoptosis observed in many solid tumor cells. Defects. So, defects, when we say apoptosis, is the cells are have the normal cell death, but it can't defect apoptosis. So, when a cell can't go through apoptosis where it can't die, so it's like it piles up. It can't be gone. So it just sit there, and then more, and then it can be seen in solid tumor cells. And this is more thoroughly can be seen resistance to killing by apoptosis when exposed to chemotherapy and radiotherapy. Next is necrosis. So necrosis, what is necrosis? Necrosis is the premature cell death or death by injury. So it occurs through swelling of cytoplasm along with the mitochondria followed by cell lysis. It is a pathological process caused by external agents like toxins or trauma and etc. Then, like radiation necrosis occurs at original tumor site, a potential long-term central nervous system complication of radiotherapy and radiosurgery. So people tend to get confused about necrosis and apoptosis. So I would like to highlight just 2 points differentiating about necrosis and apoptosis. Apoptosis is a programmed cell death, while necrosis is a premature cell death. And apoptosis occurs through shrinking of cytoplasm, and necrosis occurs through swelling of cytoplasm. Okay, moving on. And lastly, the mitotic death. The mitotic death is cells die attempting to divide due to damage of chromosome. So, where the cells, in attempt to divide itself, the cells die because of the damaged chromosome. As you can see on this figure, when low dose causes double-strand break as the dose. So as the dose increases, the chromosomes are damaged by separate break. So cells that suffer exchange site chromosome aberration are unable to survive and continue to divide indefinitely. So now that we have gone through the mechanism, we're going to see what effects do radiation cause. Okay, there are 2 effects. One is the deterministic effect and stochastic effect, which the other group has covered some part of it. Okay, so the deterministic effect is where the severity and probability increases with dose, and it has practical threshold. So it includes acute radiation sickness and chronic radiation sickness. So as you can see, we are in under a simple understanding. So for acute radiation sickness, it's not dangerous effect, while chronic radiation is a dangerous effect. Caused by large radiation dose in short time, small dose of radiation but high total amount, and then right after exposure or within 24 hours for acute radiation sickness, effect not immediately observable for chronic, easy to cure and control for acute, difficult to cure and may cause death for chronic. So for acute, there will be nausea, vomiting, headache, fever, skin and tissue burns. For chronic, like cataract, cancer, genetic mutation, temporary and constant sterility and fertility. Moving on to stochastic effect, where the severity is independent of the dose, there's no threshold, and the probability increases with dose. So there are 2 types of stochastic effect, where it is the somatic effect and the genetic. So the somatic is limited to exposed individual. Exposed individuals suffer during their lifetime, and genetic or hereditary is the where the ionizing damage the genetic material in the reproductive cells, which causes it to transmit from generation to generation, and then contribute to birth of defective descendants. Okay, this is the acute radiation syndrome, which is the mentioned earlier, the deterministic effect. To 2012 worldwide, about 400 humans had died of acute radiation syndrome. So there are 4 stages for acute radiation syndrome: the prodromal syndrome, latent period, manifest illness, and recovery or death. So the early lethal effect, deaths occur within a few weeks, high intensity exposure to radiation. Prodromal radiation syndrome. Early symptoms soon after irradiation. Symptoms vary with respect to time of onset. Maximum severity and duration depends on dose size, lasts for a limited period, minutes to few days. So we can see the symptoms can be divided into the gastrointestinal symptoms and neuromuscular symptoms. The gastrointestinal is the around the stomach, around the stomach. So what are the sickness like anorexia, nausea, vomiting, diarrhea, intestinal cramps, salivation, blood loss, dehydration, weight loss. And for neuromuscular symptoms, easy fatigability, apathy or listlessness, sweating, fever, headache, and hypertension. So here is the magnitude of dose, affect survival time, and mode of death. We have 3 levels: low dose, intermediate, and high. So around 2.5 until 5 rays. So the death can be the effect can be seen weeks to 2 months, and the effect are like bone marrow death or hematopoietic syndrome, effects on blood forming organs. For intermediate dose, around 5 to 12 grays, 9 or 10 days. Gastrointestinal syndrome, where the diarrhea and destruction of gastrointestinal mucosa. High dose is more than 100 grays. So it means the effect can be seen 24 to 48 hours, like within 2 days. So the cerebrovascular syndrome, the neurologic and cardiovascular breakdown. Cutaneous radiation injury to the skin can occur with presence of absence of ARS, non-penetrating beta particles, and low energy photon deposit exist dose only to the skin. Become apparent within hours or may not be seen for weeks depending on dose. Range from itching and tingling to epilation, erythema, edema, progressing to dry disc formation, wet disc formation, ulceration, and necrosis as dose increase. The chronic skin infection and recurrent ulceration. So here we can see as the dose increases and days goes by, skin radiation 1 on rat, the burn from 0 gray, day 7, day 14, day 30, and then it can become larger and lighter and more severe. There, the radiation syndrome, like I said, I mentioned before. Okay, for the Tokaimura radiation incident. Okay, this is gonna be we're gonna go through, and I'll be like storytelling with it. So hope you're ready to hear. Just sit back and relax. Okay, this incident is considered to be the worst civilian nuclear radiation accident in Japan prior to Fukushima Daiichi nuclear disaster of 2011. Okay, on September 30th, 1999, workers at JCO Nuclear Fuel Processing Plant, Hisashi Auchi, Masato Shinohara, and Yutaka Yokokawa poured a 7th batch of 18.18% enriched uranyl nitrate solution along with uranium-235 into a precipitation vessel. The goal of this process is to convert the isotopically enriched uranium hexafluoride into uranium dioxide fuel, which was to be used in a fast breeder reactor that can create more fissile material. However, the addition of 7 batch of solution caused a sustaining chain reaction, otherwise known as criticality, that persisted for hours. Neutrons and gamma rays were emitted, which led to eventual death of workers Hisashi Auchi and Masato Shinohara. During the incident, Auchi was standing next to a metal precipitation tank in which he was adding a mixture of various chemicals and 16 kilograms of uranium. He dumped the entire mixture without realizing that the tank has a maximum uranium limit of 2.4 kilograms. Within nanoseconds, the precipitation tank became a fully working nuclear reactor with blinding flash of blue light caused by emission of Cherenkov radiation. Auchi was blasted with 70 centimeters of radiation 300 times the annual dose allowed for nuclear power plant engineers, twice the lethal dose, equivalent to standing at the center of an atomic explosion. Misato Shinohara stands on a platform behind above him, overlooking the work, receiving 10 sieverts of radiation, guaranteeing his death, while Yutaka Yokokawa, 4 meters away, sits at the desk busying himself with paperwork, only received 3 sievert doses, 5 below the lethal limit. As the radiation tears through Aochi's body, it completely destroyed all his chromosomes, almost destroyed all his white blood cells, and covered most of his body with third-degree burns. The radiation was so intense that it burned the skin of his body inside out. So, for everyone, the next slide is going to show the actual picture of Aochi's body, so don't be alarmed. Okay. Aochi's condition deteriorated over the next few months until his death 83 days later. The mortality rate of the similar amount of radiation he received was over 100%. In 21st December, Aochi died of multiple organ failures despite being put on life support. So, what can we learn from this incident? What should we do? Now, we need to protect, and protect. So, it's only radiation protection. And okay, so what are the list of radiation protection that we can apply, that we can learn or apply? So, for instance, here the STD, shielding, distance, and time. So, the principle of reduction of external exposure. So it's like, okay, distance. For distance, it's like you're furthering away from fire. So in this case, it's the same. It as dose rate decreases as the distance increases. So for shielding, place something heavy. I mean, place something which are properly according to the type of radiation being exposed, and then shorten the time while being close to the material at the time. So exposure dose decreases at the time shorter, and so we limit ourselves by exposing it. And then we use personal dose monitoring. So for workers who are normally exposed to radiation, use individual monitoring device approved by regulatory authorities such as thermoluminescent dosimeter, time gauges, ring dosimeter, and optical stimulated luminescent dosimeter. So it's like we have keep tracking of the radiation whether how much we've been exposed to radiation, and make sure it's under prescribed effective dose limit. And this is already the prescribed effective dose limit for the nuclear energy worker, pregnant nuclear energy worker, person who's not a nuclear worker. As you can see, effective dose limit within 50 micros, 50 sievert, within below 50 millisievert, 400 or 1. So organs or tissue. So like 1 year decimated period, 1 calendar year, skin, hands and foot also include, as you can see here. And then the radiation shielding. Okay, so as you can see that the different types of radiation has a different capabilities of penetrate. They have different penetrating power. So alpha rays, it can be just stopped by paper, beta ray thin aluminum plate, gamma ray by lead, and neutron is water paraffin. So as in conclusion, from this topic, now that we know about the lethality of the radiation, we should know that we have known, we should learn from it, and we should apply on ourselves as like applying all the safety rules as to protect ourselves from the radiation. So that's all from me, from my group. Thank you everyone for listening my presentation. That's all. Thank you.
Thank you, Lukman, for your presentation. You can unshare your screen now.
All right.
All right, now we are going to move on to Q&A session. If you have any question, you can actually type in the chat box.